So this is very nice because magnetic field is 0 here, because suppose this is xy plane, okay, this is x, y and z. Suppose this is the axis. So magnetic field is function of rho. Rho in cylindrical coordinate is nothing but what is the radius in xy plane. Suppose this is rho, okay, this small distance is rho, this is rho. So rho is having value from 0 to r. First of all, you should understand this in cylindrical coordinate. And to get a small magnetic flux, what we should do, at a distance rho, let us take a small area like this, okay, this. So that will be how much? D rho into 2 pi rho into magnetic field, which is K rho cube and T cube. So this will be small flux, a small magnetic flux, and total so this D rho will be given by this. So your phi B will be 2 pi K T cube integral rho to the power 4 D rho from 0 to r. Correct? So it will be phi B is equal to 2 pi K T cube into r to the power 5 by 5. Correct? And EMF will be d phi B by dt, only magnitude is required. So differentiate this, it will become 6 pi K T square r to the power 5 upon 5. So option A is correct. So this is very, very nice question in terms of non-uniform magnetic field. Non-uniform magnetic field where flux is required to be calculated using calculus. You can't calculate it directly because every point you go, suppose this is xy plane, so starting from here, everywhere magnetic field is different. Got it?